Answers to quiz 2. This is not a frequency chart. This is just the data listed. So I'm going to type them in. 73, 73, 38. How about 385, Mr. Dueck? That's a mistake. 38, 67, 49, 95, Martin, Uter, 32. 9 pieces of data. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yay, I didn't miss any. Find the mean and the standard deviation. I'm going to go calculate, set the table. What do I want for my frequency here? 1, because there's only one of everything. It already is. You might need to change yours. Mine resets back to 0. Is the mean 68.2? Or 0.22? Or 0.2? I didn't say what to round off to. 68 I'll take, but your calculators are giving us accurate to 2 or 3 decimal places. Let's go to a couple of decimal places since we can. Let's round off properly as well. So I'll go 68.2, standard deviation of 24.3. Sorry? I would take 24.32. I would take 24.316. I would take 24.3. I'd take 24, but I'd say, oh, for Pete's sakes, let's be a little more accurate than that. By the way, is this a big standard deviation or a small standard deviation? It's fairly big. Look at the grades in Mrs. Krabappel's class. Are they all clumped together, or is there a pretty big spread? Okay, you got poor Ralph and Nelson. You got Martin way up there. Huge spread. Okay. Number 2, Barney is hired by the Quickie Mart to sample sugar content of super squishies. Find the mean and the standard deviation of the sugar content. Now they've given this to me as a frequency table, so I'm going to exit, arrow sideways, delete that whole list. And I'm going to type this list into, you could have typed it into list 2 and list 3, I guess, but anyways, 10, 20, 30, 40, 50, 10, 12, 16, 7, 2. Arrow sideways to get back to here. Calc, set the table, but this time the frequency is in list number 2. You get a mean of 25.5, 53 if you want to. Standard deviation of 11.07 or 11.1. Smaller standard deviation, that means this squishy machine has better quality control. If you had a big standard deviation, Alyssa, some squishies are getting very little sugar, some are getting a whole bunch. There's something wrong with the machine. Bigger spread means something's wonky. Machines should do the same thing pretty close to over and over, but no machine is perfect. Is that all right? So that was kind of a review a little bit. Now we did some of the new stuff, finding Z-scores. So Lisa receives a mark of 99% on her test. If the class average was 81 and the standard deviation was 12, what's her Z-score? Show work. So Z is equal to X minus the mean all over the standard deviation, which is going to be, X is her actual score, minus the average, which was 81, divided by the standard deviation of 12, dope. 99 minus 81, enter, divided by 12. Or put the top in brackets to do it all on one line. Is her Z-score 1.5? By the way, if this was a provincial exam, then the percentage that she would receive on this exam from the government would be, let me find my Z-score table. What was the Z-score? 1.5? Oh, 1.50. So she would actually get 93.32%. She would get a lower grade than her actual overall score, I guess because this test was easy compared to other tests. For 2 marks, I would go something like this. 1 mark if I saw that, half mark for the numbers, half mark for the answer. At a particular contest, judges rate classic car restorations out of 50. One car receives a score out of 36. I think that's the actual score. That's the X value. The standard deviation is 12. The Z-score is 0.5. They want me to find the mean. Okay, is that somebody at the door there or not? Okay, well, Z equals X minus, did I hit record? I did, didn't I? Yes, good. Z minus, dope, come on. Right, Joel? Let's fill in what I know. Z is 0.5, X is 36, minus, I don't know, mu, divided by the standard deviation of 12. Joel, now what? Darn right I cross multiply because I want to try and get this by itself. What's this over? It's invisible. So it's going to be 1 times that, which is just that whole thing, equals 12 times that. I'm going to get 12 times 0.5 equals 36 minus mu. What is 12 times 0.5? Anyone? Oh yeah, half of 12. 0.5 is half of 12 is 6. So this is going to be 6 equals 36 minus mu. By the way, can you do this in your head right now? 36 take away what equals 6? I think the answer is going to be 30. And if you were able to just go there, I think, Nicole, great, that's even better. But let's prove it. I want to get this by itself. I want to move the 36 over. What's in front of the 36 here? A little invisible positive or a little invisible negative? So how would I move it over? Because it's being plus technically. We don't put a plus sign, but we know it's there. Minus it. So I'd have 6 minus 36 equals negative mu. I'd have negative 30 equals negative mu. What do I do with this negative? It's technically a negative 1. We don't write the 1, but it's there. Times mu, and if there was like a negative 4, you'd divide both sides by negative 4. If there's a negative 5, you'd divide both sides by negative 5 because it's timesing. So there's a negative 1. I'll divide both sides by negative 1. Joel, what's a negative divided by a negative? I think it is. Back there's where you get the answer of 30. Now if you got 30, 2 out of 2. Otherwise, I'd probably go something like this. I'd give you a half mark if you were clever enough to clue in that it was this equation here. I would give you a half mark for sticking in the numbers. I would probably give you a half mark if somewhere along the way I saw that line, and then a half mark for the answer. Okay. Number 5. On a provincial exam, Jessica received a Z-score of 2.2 if the mean score was 63 and the standard deviation was 8. What was her actual score? Okay. Z equals X minus mu all over the standard deviation. Let's list. We know that Z equals 2.2. The mean is 63. And the standard deviation is 8. And we would like to find the actual score. We're going to get Z 2.2 equals mystery score minus 63 divided by 8. Sam, now what? I know that, but I'm asking you to play along here. What would I do to solve this? This, in theory, you know. Alexis is going to whisper a little phrase into your ear. What did she say? Did she say cross multiply? Because you're right, right? Yes, it's over 1. No, I said I wasn't going to write that over 1 anymore. I'm tired of that. Okay, so it's going to be 8 times 2.2. I'll just write 8 times 2.2 equals X minus 63. What is 8 times 2.2? I don't know. 8 times 2.2, 17.6. Sam, how would I get the X by itself? How would I move this over? Again, sorry. Add what? Yeah. Add, what am I adding? Yeah, there. So yeah, add 63 to both sides. So we're going to get this. 17.6 plus 63 equals her actual score. So her actual score is 80.6. Is that right? And again, I would probably go a half mark if I saw that. A half mark for sticking all the stuff in. probably somewhere along the way I'd give you a half mark if I saw that, and a half mark for the answer. Can you give yourself a score, please, out of 2, 4, 6, 8? It's out of 10, and I forgot to put that on the top. Give yourself a score out of 10. Please. Any lawyering with me? Now is the time. Otherwise, pass them inwards, please, as much as you did. All right, can you all find this thing here? Can you all get out the data collection lab, please? The one that I said was due today for sure. The one that you might not have if you were away 3 classes or 2 classes. How to do this? Do you mind if we use yours? Okay. Kayla had a, what was your reaction time? 0.226. So your Z-score would be bracket 0.226 minus the mean, 0.223, close bracket, divided by the standard deviation, which is 0.056. So your Z-score is that. 0.05 is what I'm going to have to round it off to, because my orange sheet only goes for Z-scores to 2 decimal places. So 0.05. Now take a look at your orange sheet. What is the heading on the top of this column right here? Look up. These are your Z-scores, okay? These are the areas. So we need to find a Z of 0.05, which is that right there. Now that's your percentile. We would say that your reactions are faster than 52% of the population, 0.52, which means you're just barely above average. Anybody get his, on this one, get a Z-score over 80? Sorry, a percentile over 80%, like 0.8? So Kiara, what was your time? Your reaction time? 0.29? The number you had here was 0.29? Then I think you get, oh, sorry. In this one, do you want your reaction time to be slower or faster if you're a good athlete? Faster. So actually, I don't want a reaction time in the 80s. That means you're slow. I want a reaction percentile. I want a percentile in the 20s or in the 10s. And anybody get a really low percentile here, because that means you've got good reflexes and good reaction time. Jacob? No? So what did you get? What did you get here? What did you get here? What did you get here? 0.24 seems about right to me. So you would go 0.24 minus 0.23 divided by that. You'll probably have a Z-score right around 50%, right around 0.5. Sorry. You'll have a percentile. What did you get for your Z-score? Oh, okay. This is what you're supposed to do for homework. Okay. Tell me what number you put here. You need to learn this, so this is the time to learn this. Tell me what number you put there. Okay, get your calculator out. It's going to be your value minus the mean. 0.24 minus 0.223. Press equals. Divided by the standard deviation. What'd you get for your Z-score? So 0.03, that's your Z-score. So 51.2%. You're slightly slower than average. Now we'd have to do this, if we were doing this properly, because average is 50, right? And a higher percentage means you're slow, a lower percentage means you're quick in this particular example. We'd have to do better research if we wanted to use this for actually calculating your athleticism. I'm willing to bet, though, that Ashley, if we did this, let's say for 200 students, and then 30 NFL players or NBA players or Major League Baseball players, I'm willing to bet most of them would have a very low Z-score. I'm sure reaction time contributes to your athletic ability. It would make sense to me. It would make sense to me. How many of you came to senior ball games, senior boys basketball games at all this year? Okay. I'd be interested in finding out Mitsu's reaction time. How many times did you see him steal the ball from somebody before they could even twitch, right? He seems to have pretty good reaction time. Okay. Did anybody appear to be psychic in the rock, paper, scissors? Did anybody get a percentile above 80 or so? Yeah? 95? So we would say either you're psychic, or you know what, actually once in a while you should win a bunch. But if we did that game over and over and over and you still kept getting a 95 percentile, how many wins did you get? So if you still kept winning 7 or 8 or 9, then we'd either say you're cheating, or you're very good at reading someone's body language and reacting in a split second to what they're going to do, or anticipating what they're going to do, or you're psychic, which is probably not the case. Okay? What we want to do today is just practice kind of applying how normal distributions work. I did a lesson with you last day, but I have a feeling it confused a lot of you. What I've done is I've just typed up a bunch of examples that we can work through together. So, patience. So we had a little discussion about this here. I'll be coming around later to actually check this in class. So don't hand it. If you did, that's fine. I'll go check in there too. But I'll be coming around to see if it's done. If it's not done, what you're saying is you wanted to stick around after school and finish it. Meanwhile, I just gave you applications of the normal distribution. And then I said in the instructions, draw a sketch for each question. It'll help. It will. I'll show you what I mean. I thought the textbook, we did the lesson last day, I didn't do enough examples with you. So let's walk through this. You have your graphing calculator handy, have your Zscore sheet handy. A company manufactures 42,000 batteries each year. From previous research, they know that their batteries have a mean life of 24.5 hours. So they're small batteries, and they'll give you just a little over 1 day's worth of playing time if you play them non-stop 24/7. With a standard deviation of 4.5 hours, and they know they're normally distributed, which means it's going to match that bell-shaped curve. Okay. Emma, what does A want me to find? Can you read? Okay, here's what this is really saying. If you sketch a little curve like this, yoink. Doesn't have to be really, really pretty, but make it kind of bell-shaped-ish. What number goes right there? Well, if it's the standard normal, the mean is 0. What's our mean here? 24.5? We want to find what percent of the batteries will last less than, Sam, last less than what? Okay, here's 24.5. Am I going to put the 18 over here or over here? Is it below the mean or above the mean? So let's put a little hash mark. How about doink right about there? There's 18. And if they want a percentage, what they're really saying is they'd like that area. Problem. My orange chart that has all the areas on it doesn't have areas for a mean of 24.5 and an 18. What I need to do now is I need to find the Z-score that goes with 18. And I write that, Nicole, by writing the letter Z, and then as a little subscript, the actual X value, the Z-score that goes with 18. You know, how about right over here, we go like this, in a box, Z equals X minus the mean all over the standard deviation. That way we don't have to keep looking it up. For this question, what's my actual measured value? What's my X value? I'll give you a hint. Yeah, 18. We want the Z-score that goes with 18 minus, Alyssa, what's the mean? Okay, so you got to be able to read. These are word problems, but they're not too bad because there's key trigger words like mean and standard deviation. I'm not going to try and hide those words. I'm either, Alyssa, going to call it the mean or the average. I don't think there's anything else I'll call it. 24.5 divided by, oh, Alyssa, what's the standard deviation? On your own right now for practice, because you need to know how to do this, can you find the Z-score that goes with 18? That means you're not looking anything up yet. You're finding the Z-score. You need to type this into your calculator. Find me the Z-score that goes with 18. Yeah. It's going to be negative, I can guarantee you that. Something weird on your calculator? Okay, hang on, don't clear it. So when I type this in, I get bracket 18 minus 24.5, close bracket, divided by 4.5. What'd you get, Joel? Yep, go ahead. It has to be negative because it's a smaller number minus a bigger number on the top.
Negative 1.444.
Like that? Good. So what's our Z-score? Negative 1.44. Okay. What are we saying here, Alexis? We're saying on this curve, when the mean is 0, 18 is a negative 1.44, and that is on my orange sheet. What we're having to do is do a quick sketch so we can figure out, are we going to the left or to the right for our area, Kayla? But then we've got to change everything into Z-scores. What is the area to the left of less than 18 hours, or negative 1.44? Okay. Negative one, oh, I'm in positive. Negative 1.44. You get, is it 0.0749? Okay. How do we write this? The probability, or P for percent, that your X value is less than 18, that the battery will last less than 18 hours. Or you can write out, Alyssa, the probability that the battery will last less than 18 hours. I'm good with that, but am I going to write an English sentence if I can use math notation? No. Is, what was it? 0.07 what? Or 7.49%. If they want to go to a percentage, I times it by 100, which means the decimal moves over 2 spots. No, as I said, you can also write out the probability is. However, I'm going to start to use that notation, so I may ask you questions with that notation gradually, so get familiar with it. So here's the question, Rachel. What percent of these batteries will last less than 18 hours? How many batteries did we make? 42,000. So how many batteries will last less than 18 hours? 7.49% of 42,000. That's what I think to myself, and since we're taking notes right now, I'll write that down. How do I find 7.49% of 42,000? Well, the first thing is I can't do any arithmetic with a percent. I've got to change it back to a decimal, which conveniently is right there for me. Remember what I said last day? What does the word of mean? Joel remembers. How many batteries are going to last less than 18 hours? I have no idea. Someone, 0.0749 times 42,000. Nope. Is that it? Can we have 0.8 of a battery? Not really. It doesn't make sense. Like, batteries don't come in chunks, right? So I think I would round this to 3,145 or 46? 46. Is that okay? So what we're going to be looking at for the next little while is, if I give you actual values, find the Z-score that goes with them. Do a sketch to figure out what area you're interested in. That's why the little picture of the bell helps. And then sometimes I'll ask you to do something with that percentage. C. What percent of the batteries will last more than 30 hours? There's our bell. That number is the mean. What was the mean? 24.5. 30, is that going to be to the right of 24.5 or to the left of 24.5? To the right, like over here somewhere. And they want, which area? Do they want me to go below 30 or above 30 when I color this in? And how can you figure it out? Alyssa, what? More than, would that be then to the right of 30 or to the left of 30? Ah! Other words, greater than, above, longer than, those would be to the right. Words that would say to the left, smaller than, less than, shorter than, weaker than, well, it depends what you're looking at. Joe, why'd you turn your head when I said shorter than? Anyways, okay. Is this okay as a picture?
Yeah.
Here's the problem. Your orange sheet doesn't have a 24.5 there. What does your orange sheet have right there in the little picture on the page on your orange sheet? Does it have any number there? I can't remember. Yeah. What did your orange sheet have right there? 0. And what letter does it have right there on your orange sheet? Z. I need to find a Z-score. I need to find the Z-score that goes with 30. How? Just like we did here. Except, what's my X value this time, Kiara? $30. Yes, that number, that's the Z-score I'm finding. So 30 minus 24.5 divided by the standard deviation. What's the Z-score that goes with 30? And I'm deliberately not doing this on my calculator because too many of you are just copying what I type. You need to be able to find this. If you can't find this, none of the rest of this will make any sense because your Z-scores won't be on your table. Sam, what'd you get for a Z-score? Should it be positive? Are we above the mean? Yeah, this should be positive. 1.22? Yes? Anyone else? Yeah? Yeah? So here's what we're saying. A 30 right there is the same as having a 0 for your mean and a 1.22 right there. I want to get this area. Now here's the problem. Your orange piece of paper, your Z-score table, Jacob, doesn't give you the area to the right. Which area does it give you? Can you find that area for me? The Z-score area for a Z-score of 1.22. Find it. Sorry? I don't know, is it? 4/8? Really? That's nice. That's a fluke. 0.8888? By the way, if you aren't drawing this picture and drawing that little arrow, all you're doing is making this tougher for yourself, I'm telling you. Some of you are like, I see you kind of lazing out, and you're exactly the ones that are also confused and not getting. I'm telling you, I'm giving you a minimal amount of work, maximum bang for your buck method, because what's the area this way? 0.8888. What's the area this way? How can I figure it out? You remember? Do you remember? Do you remember? Joel! This is going to be 1 minus, because what's the total area? 1. Okay? So you are going to have to memorize, Rachel, that if you're going to the right, it's 1 minus the area on your orange sheet. If you're going to the left, it's just the area on your orange sheet. And how to find a Z-score. Oh, that's what your quiz was about. Okay? Nikki? You can write the probability that the battery lasts more than 30 hours is, I'm going to write the probability that my X was bigger than 30 is, mine's shorter, 1 minus 0.8888. Write that down so that you remember we went 1 minus. 1.11, what is it? Sorry, 0.11 something something something? 0.1112? or 11.12%. 11% of their batteries will last longer than 30 hours. How many? Oh, how many batteries did they make? 42,000. Oh, so how many? 11.12% of 42,000. How can I find this out? Joel, what does of mean? And take the 11.2, make it a decimal, which you conveniently have right there anyways. Yes? How many batteries will last longer than 30 hours? 4,670. Is that rounded off properly? Yep. E. What percent of the batteries will last between 18 hours and 30 hours? Okay. Are they asking me to find a percent, Colleen? Or an area? Then I'm going to draw a little picture. I'm going to dollop. Those of you that are in my physics class, I'm going to go. The mean is in the middle. What was the mean? I've scrolled down. Oh, 24.5. $18 hours. Is that going to be to the left or to the right of 24.5? Put a little 18 right there. 30 hours, that's going to be to the right. Let's put a little 30 right there. Yoink, yoink. Which area do we want? This one. Ah. How do we find an in-between? Kiara, what? I agree we're going to subtract, but it tells me, she said subtract it. Okay, I agree there's going to be a minus sign. I want more specific. Hey, Kiara, do we know that area? Were we clever enough to write that on a drawing just a little bit higher on the page? For 30, we were? What was it for 30? 0.888? Oh, and do we know that area? Were we clever enough to write it on the page somewhere? What? I've scrolled down. It's way off my screen. What was the area to the left of 18? Did we do 18? Ah, we didn't do... Oh, yeah, we did. 18, right? Ah, but we didn't draw it on there? Okay. Can you look at our numbers and figure out what it was? It was 0.0749, wasn't it? Because that's where that decimal came from. Let's add it here. 0.0749. Nikki, you can write out as your part of your answer, the probability the battery will last between 18 and 30 hours is, I'm going to write it this way. The probability, what's the lowest value? Nikki, what's the lowest number of hours we want here? 18. What's the highest number of hours we want here? Leave a space, 30. We want the x value to be between them. So I'll physically put it between them. And then, Nikki, it's actually less than, like that. How does that work? This is saying x is bigger than 18 and smaller than 30, which is the mathematical definition of in between. Kiara, how? All right, what percent of the batteries will last between 18 and 30 hours? You get 81.39%? Sorry, yeah. 0.8139 or 81.39%. Most of them. Most of them. Suppose, before we turn the page, suppose another company manufactured batteries and they had the same mean but a smaller standard deviation. What would that tell you? Tell you those batteries are more consistent, probably better quality control in their factory because not as big a spread. Okay, I bought a bunch of batteries in bulk. They were really cheap. They're these right here, like $2 for a pack, a AAA pack of, I think, 20. I'm finding they have a huge standard deviation. Some last a long time, some I put in and 2 days later, they're dead. Oh, I bought cheap. You get cheap. Next page. Is it next page or next or half a page over or whatever? It's next side. Ah, so we're not turning the page. Number 2. Last year's Math 10 provincial exam has a mean score of 36 and a standard deviation of 13. Assume the scores are normally distributed. If a student scored a 47 when they wrote the test, what's their Z-score? Try that one on your own right now, please. I'll freeze the screen and do it up here, but you can try it on your own. You get a Z-score of 0.846153, blah, 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 blah. What are we going to round this off to? 0.84 or 0.85? Because we got to go to 2 decimal places for our chart, unfortunately. Yeah, so 0.85, and that would make it probably a difference. That's their Z-score, 0.85. What percentile would the student from A be in? This is the percent they would receive on their transcript. So here's their Z-score. What percent above the rest are they, and therefore, what will the grade be? Nicole. Is that right? 0.8023? Or 80.23%. Okay. I didn't draw a picture for this one because they kind of walked me through it, but here's really what we're saying. You want to draw a little picture over here. The mean was 36. The student got 47. We found their Z-score to be 0.85, and we wanted the area to the left so that we could find out what percent this student was above, and therefore what they would get as their grade, which was 0.8023. Does that make sense? Carrie, you gonna make it? You sure now? Take your jacket off if you're gonna go sleepy. Well, but the reason you're sleepy is because you've got your jacket on. It's cold, it helps you stay. It's up to you. Or sleep, I don't care, I'll just make fun of you. All right, so you saw how we did A and B? What if instead of getting a 47, what if they got a 32? By the way, 32, below average or above below the mean or above the mean? What was the mean? 36, Alyssa? Are they below the mean or above the mean? I guarantee they're getting less than 50% then. Their percentile, they flunked. Can you try this on your own? Find the Z-score, draw a little picture, find the area below 32, or whatever the Z-score that goes with it is. Am I right? No, people are shrugging. I might have read it wrong. Do you get a negative 0.31 as your Z-score or not? Okay, maybe I read it wrong because I don't have the headings the way you guys do. 1.3, 3783? I am right? Oh, okay. So you think about that. Actually, this kid's only a tiny bit below the mean, but well below passing. I guess this test was considered, based on the standard deviation, to be fairly easy compared to other tests that year. Okay. How many of you got that one okay? Good. What percent of the students scored between 36 and 50? Let's draw a little picture. Question, Nicole? By the way, common mistakes, and Nicole, you're right, when you're reading the chart, reading the positive lines instead of the negatives, or it's a little strange because on the negative side, it goes from 9 down to 0, and on the positive side, it goes from 0 up to 9, so make sure you're in the correct column. That's the thing I always find tough. What percent scored between 36 and 50? Okay. The mean is 36. Oh, and that's the first score they want me to deal with. Where would 50 be? To the right or to the left? Over here somewhere? And Tanner, we would like to find that area. How? Well, we're going to go this. Take away that. How? Find the Z-score that goes with 50. Find the Z-score that goes with 36. Try those on your own first of all. That means you'll have to write stuff down and do some work. Oh, you already did? Okay. .08. Oh, that makes sense. Because the mean is 36 and the mean on the standard is 0. So I think for the 36 you should get a Z-score of 0, right? Average. You get 1.08 for your first Z-score, for the Z-score 50? Yeah. Okay. What is this top area? What's the area to the left of 1.08? That I gotta look up. 1.08. You get 85.99? So 0.8599. By the way, without using your table, what's the area to the left of 36, to the left of a Z-score of 0? It's got to be 0.5. It's half of it. I could look it up and it's on there, but what's the area between them? And Nikki, I'll write it this way. The probability that 36 was my lowest score, 50 was my highest score, and a kid scored between those two. The probability that we scored between there and there, or what percent of the students, because probabilities are out of percentages as well. 0.8599 minus 0.5. Is it 0.3599? What that means is, if this was accurate, and I made these numbers up, Tatiana, but if this was accurate from last year, if I randomly picked any one of you, I'd have a 36% chance that you got between 36 and 50 on the provincial exam last year. Because 36% of the kids did. So that would be the odds of me guessing right at random. Okay. Rachel, is that okay? Yeah, yeah? couple more, we're done. Number 3, I'm going to let you try for homework. Let's try number 4. Now, number 4 is a little bit different. On the previous few questions, what I've done is I've given you the X score, which we turned into a Z score, and I've said, find the percentage, find the area. In number 4, I'm going to reverse the procedure. Nicole, I'm going to tell you what percentage, what area we want, find the Z score that goes with it, and use that Z to find the X score that it originally came from. Say what? Read along with me. This year, BC Fisheries notices that the average salmon has a mass of 32 kilograms. So let's say they caught 1,000 sample salmon, they weighed them all, they measured them all, and they found there was a standard deviation of 3.5 kilograms. I made these numbers up, but they do this type of research all the time. BC Fisheries wants the smallest 97.72% of the fish to be released when caught. They want some to go back into breeding stock. Why 97.72%? Because I had to find a number that was on your chart. In real life, they pick some biologically useful percentage and use a computer to find the Z-score. But I had to be stuck with your chart. What Z-score has 97.72% below it? 2.00? Even? Positive or negative? So here's what we're saying. I draw a little picture with a Z right there of 2.00. This area here is 0.9772 or 97.72%. But this here is a Z-score. Colleen, what do they want me to find? Part B. Read to me. Okay. They want the actual weight limit, right? Colleen, do we know the mean? Yeah, read carefully. Did I say the word average up here? 32. Do we know the standard deviation, Colleen? What? Do we know the Z-score that goes with 97.72%? Yeah. From the chart. This is now I'm giving you a percentage, so we found 97.72%, which was 2.00. Okay. By the way, again, Kayla, in real life, they probably say the top 80% or something like that, but some of those numbers aren't on here. Computer software would help you find the Z-scores to go with them. I don't have a number here for exactly 80. That's pretty close, but whatever. I wanted to pick a number that was blatantly on there. Is that okay? So that's where the Z equals 2.00 came from. Colleen, what do you tell me they want us to find? They want me to find X. This is, if I know 3, I know 4. This is, we're going to use Z equals X minus mu all over the standard deviation, just like we did on the quiz. Z, 2 equals X I don't know minus the mean, 32 divided by standard deviation, 3.5. Can you find X, please? Joel, how am I going to solve this? Yeah, cross multiply. That times that. 2 times 3.5 equals X minus 32. Emma, how would I get the X by itself? What would I do with the minus 32? Did you say add it? You'd be right. So if I hear you correctly, you're saying X is going to be 2 times 3.5 plus 32? You are correct, madam. What size limit or what weight limit would we put on salmon this year? 39 even? So if it's less than 39 kilograms, release it. If it's bigger than 39 kilograms, keep it. Most of the breeding stock goes back into repopulating the salmon. Okay. Is that all right? I hope that kind of cleared and cleaned things up a little bit from last day because people seem confused. So, sleep for 10 minutes. What's your homework? Well, I'm going to say try the ones on this sheet. You won't be able to do every one of them. And also, in the next lesson, I'm going to show you how to do some of this on your graphing calculator, which is why I haven't given you the answers. I'm going to show you how you can check your answers really, really quickly. But also, can you open your books, please, to page 239? I already assigned numbers 1, 2, and 3, and 4, and 5, and 6. You can also include number 10. Page 239, I think is where I was. And we're going to pause there. So I'm going to be coming around to look at some lessons and the data collection sheet.